Right. This is the PLA. This is the polycast, and you can see these are the original size parts, and then that's how I'm trimming them down. And then you can either take hot glue or super glue. I've already kind of glued this on with super glue. We got all the plaster for the most part out of it. You see how rough these edges are? And that's from cutting it. You see how rough it is here. So we're going to trim that out, clean it out. This one doesn't need a lot of cleaning on the inside. It formed pretty good. And we're going to use that to make our connections. We're going to do a total of 600 grams, so 480 grams is going to be 80% of that 600. So you just take 600, multiply it by 0.80, and that'll give you how much plaster of Paris that you want. So you want 80% plaster of Paris. Now we need to determine how much talc. We want 15% talc. Let's see what. Now we're going to need about 30 grams of Portland cement. There we go. Mix this up. So now we're going to take about 300 milliliters of cold water. Now this is really cold, so it may take it even longer to kind of set, but we want some time, and we want it to be kind of thin as well. So it'll pour into that mold. Not be enough to fill up everything. But at least if we can get to the point that it covers most of it, we'll be doing good. Force it down, but again, you would want this to go all the way to the bottom. My other thing I could have done is taken that other portion of the sprue off, or cut part of it off so it wasn't so tall. This part is a little bit taller than the other ones, but that's okay. It's still going to work. A hand mixer for this. It's going to create a lot of dust even at the lowest setting. All right, we let this thing dry overnight, so it's had more than 12 hours. But at a minimum, you want 12 hours. And we filled in the bottom, so you're looking at about 800 grams total. So yeah, it's 4 and roughly about 4 wide. So that's a 4x4 piece of stainless steel that we're pouring into. You can use coffee cans, but they may burn up. So I've been using the stainless steel. I just purchased it and then purchased these. These are great because it gives you that nice little pouring spout. So now we're going to 80% plaster of Paris, 15% the talc, and the other 5% from Portland cement. Now I've kind of played around with that where I've gone 70, 20, 10. Take our cast, put it in there. Equal distance from all the sides. We'll lock that down. This is an electric kiln. We'll keep this at 150 Celsius for 2 hours, and we'll do each one of these phases at 2 to 2.5 hours. So the next one we would bump up to is 350 Celsius and do that for about 2 hours, and then we jump up to 700 Celsius. But I do that normally anywhere from 2 to 2.5, and that's really your burnout phase. And then we got to cool it down. I normally cool it down for about 2 hours, and I bring it back down to 200 degrees Celsius, 200, 250, somewhere right around there, and I do my pour. Oh yeah, that's super hot. So this thing is really hot, so we got to make sure it's not too close to anything it can melt. So this is red hot. Just taking the top part of that and getting any little particles or trash. And that'll stay molten for quite a while to avoid it cooling off too fast and going into thermal shock and breaking. And this thing will slide out of here, so that's why I need a bottom on it. Bring it over here, make sure it's not going to touch anything. Make sure nothing is in our way. All right, that looks good. We're going to pour that right down in there. This is super hot. There we go. We'll put it back in. So the aluminum that we're casting is still hot, but we kept the mold hot as well. It's 500 degrees. Now I would normally let this cool way longer than this, but I'm going to end up redoing these parts because these are ones that I trimmed down by hand, so they have some rough edges on them. They don't look as good. I'm just using them for the first assembly of these parts. So this is really gonna bubble when I drop it in there. Like I said, normally I'd let it cool for about 2 hours before I drop it in there. Really hot. So it's gonna explode. Look at that, the bottom cracked just from the thermal shock of being out here. We'll let that cool off and I'll show you. So this is still going to be, like I said, super hot, so do not grab it. It looks like it turned out pretty good from the bottom part. Let me move that around so that you can see. You can see the bottom part of that where it broke away. What you see there, this separation, is where I didn't have enough. I started off with 600 grams total, and it filled it up to that level. And this is where the second layer came in, and it broke evenly along that. Like those two, this had already hardened enough, so those two didn't bind. I thought it was still going to be soft enough so they would bind. So you can see here, this is the sprue that mounts to the top of the mold. This is the sprue that I made for the 3D print. These parts, you can see they have rough edges out here. That is because I cut down a full-size part. We needed the full-size part for small-scale production, or if we were going to skin these with carbon fiber or fiberglass. But with the metal parts, we don't need them to be that big. And so I'm going to reduce the size of it for casting. And if we print these off with 3D metal printing, we need it to be smaller to reduce cost there as well. But we're going to do the casting first. But I didn't want to waste those parts, so I'm like, well, at least we can get our mixture down, we'll get the process down, and then once we master it, we'll use the newer ones. Now I used polycast for this. That was that white material. If you're going to use polycast, you've got to use it right away because it will dry out pretty quick. PLA, this was made from PLA, and you can see it worked just fine. So I think I'm just going to start printing the parts in PLA. I don't need to incur this type of cost if the PLA is working fine. We don't need a lot of detail. Take my reciprocating saw, and we're just going to cut that right off where the sprue goes into the part. I'm going to clean up any residual plaster that's on there, and then we'll melt this down again and reuse it so we can save metal. And then there's our part connections. This is the part here that we just printed, and it does need quite a bit of cleaning up. So we've got to get all that plaster out of here.